Visit Chandra's beautiful universe. NGC 6278 and PGC 039620. Most smaller galaxies may not have supermassive black holes in their centers, according to a new study using NASA's Chandra X-ray Observatory. This contrasts with the common idea that nearly every galaxy has one of these giant black holes within their cores. The team of astronomers used data from over 1,600 galaxies, collected in more than 2 decades of the Chandra mission. The researchers looked at galaxies ranging in heft from over 10 times the mass of the Milky Way down to dwarf galaxies, which have stellar masses less than a few % of that of our home galaxy. The team has reported that only about 30% of dwarf galaxies likely contain supermassive black holes. This study gives clues about how supermassive black holes are born. It also provides crucial hints about how often black hole signatures in dwarf galaxies can be found with new or future telescopes. As material falls onto black holes, it is heated by friction and produces X-rays. Many of the massive galaxies in the study contain bright X-ray sources in their centers, a clear signature of supermassive black holes in their centers. The team concluded that more than 90% of massive galaxies, including those with the mass of the Milky Way, contain supermassive black holes. However, smaller galaxies in the study usually did not have these unambiguous black hole signals. Galaxies with masses less than 3 billion suns, about the mass of the Large Magellanic Cloud, a close neighbor to the Milky Way, usually do not contain bright X-ray sources in their centers. The researchers considered 2 possible explanations for this lack of X-ray sources. The first is that the fraction of galaxies containing massive black holes is much lower for these less massive galaxies. The second is that the amount of X-rays produced by matter falling onto these black holes is so faint that Chandra cannot detect it. The team concluded that based on our analysis of the Chandra data, there really are fewer black holes in these smaller galaxies than in their larger counterparts. This result could have important implications for understanding how supermassive black holes form. It supports the theory where giant black holes are born already weighing several thousand times the Sun's mass.